Alvin, JR, and Quinn.
And that's Jeff.
Yes.
I'm just the video guy.
Okay, so the first hardware robot that I'd like to show you is a 3D printed phone mount. This is the first time we use a 3D printer, and it took a couple of tries. The first couple were a little messed up, and we had to put glue on the plate that the 3D printer printed it on, so it wouldn't peel up.
The next thing is the drivetrain. So we decided to go with a chain and sprocket system. What we have is a motor that runs a center sprocket that moves out to the outer two wheels. And these, from those sprockets, go to these two sprockets to invert it back to the center wheel. So what happens is the single motor is running all the wheels on one side. That way we don't have to worry about syncing motors up for individual wheels. And it allows us to move the center wheel further up. That way when we're going over the crater in the game, the center wheel will help us push us over. That's why it's a little bit raised. So when we're in that kind of middle ground, when one wheel is on each side, it helps propel us over.
We also put like the tape for baseball bats on it so that it has more grip.
Right here.
So our original idea for the arm was to have a double 4-bar linkage system that would accordion out when we had issues programming the motors and getting the motors to work correctly. We decided to scrap that and instead use a linear slide. For that, we have a motor in there with paracord that coils around a center shaft, and when the motor goes one way, it turns it and coils the paracord one way and pulls it up, and then when it rotates the other way, it pulls it down and coils the other side up. We also have a hook that is a carabiner from Lowe's, and yeah,
That's a heavy duty one.
The arm was originally going to be our way of getting the gold and silver, so we had to come up with a new design. The crossbeam here was built to attach A because the arm was crabbing out, and so it was to keep it to stay straight because we were beginning to have issues. And then we built the two designs programmed for both. We have the claw, which is what we're going to be using today. It's pretty simple, just kind of grabs the minerals. I have rubber bands here as grips, pick stuff up. Then the other one that we're going to possibly use is a bucket, and this spins to get the minerals into the bucket. However, we were having issues programming this, and so we were pretty much forced to use the claw.
Well, it wasn't a programming issue, it was mounting it within the requirements for the robot.
And another problem we had with it was we didn't know if we could get over the crater with the design we had. So we were trying to flip it over and see if it would work yesterday, but it didn't work out very well, so we're going with the claw.
So for the programming part, we started using Android Studio for the autonomous, and we translated that over to Onbot Java because it was just easier to have all of the program in one spot. And for teleop, we've got two different controllers. One's for the pulley mechanism, and one's for the claw. And then the other controllers for the drivetrain. And so with that one, we were trying to do Onbot Java for programming that, but we were struggling with the measurements and stuff. So what we did is we just changed it over to Blockly, and that's been working a lot easier for us because it's faster for me to program. And I made two different backup plans in case whatever I've already programmed hasn't worked. So we have two extra programs that we can run.
Okay, so for our trophy, we designed to do a strand of DNA. It was built by me, super glued by me. Yeah, and we also designed this trophy box. Well, Quinn and I did that by using cardboard and a knife from a kitchen. So I cut it out. I cut out the pieces, and Quinn taped them together, and we wrapped it in duct tape so that it would look a little more fancy. And we slapped some stickers on there to make it pretty.
And our sponsors.
Yeah, our sponsors.
Yes, and our sponsors.
Yeah, After I got my wisdom teeth taken out 2 days later, I was sitting there on the couch wrapping it in tape and slapping a NASA sticker on it.
And we attached it to here so that it would stay within the size requirements, but it would easily tip out and fall down into the designated area.
One of the ups and downs of our programming, Android Studio is new to all of us. For the longest time, the biggest problem we encountered was actually getting Android Studio onto the computer. There were issues with files not being recognized by the computer in order to launch certain things with the FTC programs. So we had to go in and manually find them through the hard drive of the computer, search through it and find them and link it. But once we got that out of the way, the next thing we had to do, we used telemetry in our robot a lot to get encoder clicks returned. And once we had that out of the way, the rest of the coding in terms of the autonomous and the onbot was actually easy compared to getting telemetry set up, because it was just taking angles of the actual playing field and measuring wheel size and drive distance and things like that, instead of software to hardware. It was just hardware. So that was the big thing.
For our outreach part, what we did a lot of demonstrations. We did one at our youth fair in Berkeley County, and we were a 4-H club as well, so we did some at our 4-H extension office. And there was actually in the notebook, one of the kids that met us at the youth fair, his parent emailed us. He was, I think he's 7, and he's not an autistic child, and he had like trouble finding things that he liked doing, and we let him mess around with one of our robots a little bit, and he was really interested in it, and now he wants to be in a robotics club, so that changed what he wanted to do. And then we said we got sponsors. We've got one on our robot, Exit Realty, and we went around and asked for money in exchange for certain things. Like we've got people on our t-shirts, stuff like that. So marketing for them and money for our robot.
Some other problems we encountered when constructing our robot were the size dimensions. We had some problems with the wheels being too far forward, so we had to bump them back a hole. And then we also had some problems with the motors in our first lift. So it was a super heavy, when it was extended, it was really heavy, and the motors couldn't control it when they slammed back down. So it was kind of damaging the robot a little bit. So we bought rev motors to try to control that more after we burnt one of the former motors out. So that was one problem we encountered, and we eventually stopped that idea and constructed that.
Yeah, the programming was forceful enough that when we would lift it up, we had some physical stops to make sure, because one of the issues we were having was the claw here was just barely touching the ground, and we didn't want to ruin the mat, so we had some physical stops because it was there was just a little bit of slack because of the gear ratio. So we had a physical stop just to lift it up just enough, and it was coming down hard enough that the physical stops actually bent on the robot, so we decided to move on from there.
Yeah.
Do you guys have any questions for us?
How long have you guys been together?
It's our first year.
Yeah, this is our first year. We're really
I'll say, what, 4 months?
Yeah.
A lot of us have done FLL before. I've done FLL for 5 years.
I've done it for 6. Quinn, how many have you done?
I think it was 1.
A lot of us have done things through this STEM group, but this is
Dave,
our first
Nate,
year doing
Dave,
yeah.
Nate, Calvin, and I have done Team America Rocket Challenge through the same group.
But this was our first year
And
doing
then-
FTC.
We've done some block programming
Yeah.
with the Lego robots for independent groups outside of this one.
Yeah, most of us are in different parts of the Lego League. We all know each
Some
other.
with this group, but
So Gabe, Calvin, and I went several times to various science fairs, rocketry projects, gained knowledge from this.
Sarah and I went to WRO.
Yeah, we did
Robot-
WRO
yeah.
too.
Allison was also there.
We were also able to, during this season, we were able to go on to a radio show.
Oh yeah, we did go on the
message.
radio a couple of times, and they talked to us about how our robot was doing. We're friends with the people at the radio, so they like having us on.
And then I've known her long enough.
Yeah, and it's good outreach too. It gets our name out there.
Are you affiliated with the school or? Can you...
We're a 4-H
No,
club.
we have some from a school at the south end of the county, some from the north end of the
Yeah,
county,
we're from
some
everywhere.
near homes.
Well, thank you for listening to us.
Mhm.
Yep.
How did you design your shirt?
Well, came up with a bunch of different names.
And
And we just thought that it would
It was
be
actually funny.
funny.
We had a giant list of names and went to vote on it, and then when we got when we had our final name from the majority vote, somebody just threw a name out there at the last second, and we were all like, you know what, we like that one better.
Good choice. Good job. Good job with your presentation.
Thank you.
Thank you.
Have fun with that. Have fun.
Red bucket.